For this problem, we're given parametric equations and we're asked to graph the plane curve. We have x is equal to t squared and y is equal to t minus 1 with the restriction negative infinity is less than t is less than infinity. We want to eliminate the parameter and then graph the plane curve, and we'll use arrows to show the orientation of the plane curve. If we want to eliminate the parameter t, it's best to take one of these two equations and solve it for t and then use substitution. Looks like it'll be easier to solve the second equation, y equals t minus 1 for t. And if we do that, we'll add 1 to both sides and we get y plus 1 is equal to t. Now we'll take y plus 1, which is equal to t, and substitute it in t in our other equation. And we'll have x is equal to t, which is y plus 1, quantity squared. We can write this in standard form as y plus 1 quantity squared is equal to x. This is the standard form of a parabola that opens right. And the vertex of this parabola we can find, it's of the form y minus k quantity squared equals 4p times x minus h. So our vertex is going to be at the point h comma k. H in this case is just 0, and k will be negative 1. So let's take this information and put it on a graph. Here's our equation in standard form. We just found out that the vertex was at 0, negative 1, and it opens right. So 0, negative 1 is right here. Let's pick a couple other points so we can do a sketch of this parabola. Let's let x equal 1. If we let x equal 1, then we get y plus 1 quantity squared is equal to 1. If I take the square root of both sides, I get y plus 1 equals plus or minus 1, or y equals negative 1 plus or minus 1. Negative 1 plus 1 gives me 0, or negative 1 minus 1 gives me negative 2. So we have 2 points now. When x is 1, y could be 0, which is right here. Or when x is 1, y could be negative 2. Now, we have a sketch of this parabola based on this information. But we want to do one more thing in this problem. We want to make sure that we use arrows to show the orientation of the plane curve. And the arrows are really dependent upon t. So let's come up with a chart so that we can find out the direction of our arrows. We'll have t. We'll also have x, which is equal to t squared. And we'll also have y, which is equal to t minus 1. And we'll have a corresponding point, x comma y. Remember, the original restriction was that t could be any real number from negative to positive infinity. So let's just start by picking a couple of different numbers. Let's let t equal negative 1. If t is negative 1, then x is equal to t squared, or negative 1 squared, or simply positive 1. Y equals t minus 1, so that would be negative 1 minus 1, or negative 2. So we have the point x comma y on the graph, or 1 comma negative 2, which we've plotted right here. Letting t equal 0, x, which equals t squared, is just 0 squared, or 0. Y would equal 0 minus 1, or negative 1. And then we have the point 0, comma, negative 1. This is important to see the direction orientation of the arrows. When t was -1 right here, we got the point 1, -2. Now, when t is increasing up to 0, we got this point, -1, 0. So we can see our arrows are going in this direction. Let's do one more point by letting t equal 1. Then x will be t squared, or 1 squared, which is 1. And y will equal 1 minus 1, or 0. And we'll have the point 1, 0, which is right here. So this represents t equal to 1. So we can put our arrow orientation on our plane curve.